My dear students, we are seeing in previous videos our syllabus of operating system, chapter 2. Myself, Patwari DN, working as lecturer in computer science in the Sri Shivaji College, Parabhani. As we see there, we see previous points, and this next point is that operating system generations. Generation means how to create, how to prepare or made. It is possible to design, code, and implement an operating system specifically for one machine at one site. Most commonly, operating systems are designed to run on any of the class of machines at a variety of sites with a variety of peripheral configurations. The system must then be configured or generated for each specific computer site. The process, also known as system generation sysgen. The operating system is normally distributed on a disk or CD-ROM or DVD-ROM or as an ISO image, which is a file in the format of CD-ROM or DVD-ROM. To generate a system, we use specific program, the sysgen, which reads from a given file or asks the operator of the system for information concerning to the specific configuration of the hardware system, or probes the hardware directly to determine the components, what components are there required. The following kinds of information must be determined. Number one, what CPU is to be used, what options, that extended instruction sets, floating point arithmetic, and so on are installed. For multiple CPU systems, each CPU may be described. Number two, how will the boot disk be formatted? How many sections or partitions will be separated into, and what will go to into each partition? Third point, that how much memory is available. Some systems will determine this value themselves by refreshing memory location after memory location until illegal address faults is generated. This process defines the final legal address and the amount of available memory. Next, what devices are available? The system will need to know how to address each device, that device number, then device interrupt number, then device type and model, and any specific device characteristics. Last point, that what operating system options are desired or what parameters values are to be used. These options or values might include how many buffers with which sizes should be used, what types of CPU scheduling algorithm is desired, what maximum number of processes to be supported, and so on. Once this information is determined, it can be used in several ways. At one extreme, a system administrator can use it to modify a copy of the source code of the operating system. The operating system then completely compiled data declarations, initializations, and constants along conditional compilation produce an output object version of the operating system that is tailored to the system described. Tailored means make as per requirement. At a slightly less tailored level, the system description can lead the creation of tables that selection of module from a pre-compiled library. These modules are linked together to form general TED operating system. Selection allows the library to contain device drivers for all supported I/O devices, but only those devices needed are linked into the operating system. Because the system is not recompiled, system generation is faster, but resulting system may be overly general. At other extreme, it is possible to construct a system that is completely table driven. At the code, all the code is always part of the system and selection occurs at execution time rather than at the compile or link time. System generation involves simply creating the appropriate tables to describe the system. The major difference among these approaches are the size and generally of generated system and each of modifying as the hardware configuration changes. Consider the cost of modifying the system to support a newly acquired graphics terminal or another disk drive balanced against that cost, of course, is a frequency for or infrequency of such changes. Thank you very much for watching this video.